This video is about electronics, some very basic ideas in electronics. So right now I have in front of me this tiny battery. Some people call it a coin cell battery, and if you look very closely on the front, you'll see it has 3V, 3V, which means 3 volts. There's a plus sign here. This is actually the type of battery it is. And then there's on the opposite side, there's kind of a rough area. Now, if I have an LED like this and I place it on this battery directly, well, look at that, and that lights up. So the question is, what is going on here that makes this happen? And the topic is electronics. Now, electronics is a huge, huge topic, and I'm not going to discuss it in that much detail. But there are 4 basic ideas that you should know to get started. First of all, the thing that's actually making this light light up when it does light up is that there is current flowing through it. Now, what is current? Well, current is, and I'm going to write this definition down, current, charged particles flowing in a wire. Now, it doesn't have to be a wire, it just needs to be something that allows the current to flow. Okay, so charged particles flowing in a wire, current, and when this is activated, then there is actually current flowing in one side and out the other side. All right, so the question is, if I'm holding this wire out right now, is there current flowing? The answer is no. So it turns out that in order for the current to flow, there needs to be some type of pushing force. And that is exactly what our battery gives us. This pushing force, some people call it electromotive force, kind of an older term, but it has another more familiar name. The pushing force is called voltage. So the second key idea is voltage. And this is the push that makes current flow. Okay, so when I connect this up, I put one side of the battery on the positive and one on the negative, and the voltage of the battery is what forces the current to flow. We call the voltages positive and negative. And it's important to understand that voltage is always relative. This particular battery has 3 volts, and what that means is that the positive is pushing against the negative with that relative 3 volts value. You will also notice that in order for it to actually light up, I need to squeeze these leads, these are called leads, against the battery. If I let up, then what happens is one of these leads actually moves away from the side of the battery and the current stops flowing. So the third important concept in electronics is the idea of a circuit. And a circuit is a complete pathway that starts at the positive side of our battery and goes through as many components as you have in your circuit. In this case, we just have this one other than the battery, and then ends up at the negative side. In order for any current to flow, it must have a complete circuit. So I'm going to write down that third concept, which is a circuit. It is the complete pathway from positive to negative. You can think of the positive side, the positive voltage of the battery, as being sort of a pushing force, and the negative side being something like a pulling force. So the voltage of the battery is pushing on one side and pulling with the other side. And In order for it to actually make the current flow, the pathway has to exist all the way around. Okay, I'm going to give you one more key idea. So these are three ideas. I'm going to give you one more. Hey, Jimmy, can you hand me that battery? Okay, thank you very much. All right, so this is a battery. This is also a battery. The difference is this one, actually, if you look at it closely, it is a 9-volt battery. Now, if I hook up this guy, this blue light, to this 9-volt battery, let's just see what happens. I'm going to make sure that the positive side, the LEDs do require the longer leg to be on the positive side, and I'm going to hook it up. And uh, it briefly blinked, and then it went out. Now, if I actually go back to this battery, you'll see that it's not lighting up anymore. What happened? Well, this LED just got fried. It turns out that a higher voltage means a higher pushing force, and all else being equal, that means there's more current flowing through here, and at some point, there is too much current for the little LED to bear. Current and voltage, the higher each of them is, the more power is going out into the circuit. And sometimes you have a component that can only take so much power. So this little LED is now dead. I'm going to go and I'm going to find another LED, and here it is. I'll just prove that it works on this guy. This has a certain pushing force, a lower voltage, so that means less current. Now, sometimes we need to use a 9-volt battery or some other battery, and the components that it's going to be delivering the current to cannot take that much current. So it turns out that there is a fourth quantity that is important, and that is the idea of resistance. So resistance. This is the pushback that that reduces current. So there is different resistance can come from different places, but there are actually special components that are designed explicitly for this purpose. And this is an example of one. It is called a resistor. Resistors usually have these little stripes, and there's a special code that indicates what resistance value they are. The higher the resistance, the more they push back on the current. Now, if I put this as one of the components in my circuit, then you'll notice that in this case, the LED will no longer burn out. And I'm going to go and I'm going to connect this here. So it's connected from the positive to my resistor. And then I'm going to take this guy here and let me just arrange it so it'll actually touch. And let's see if I can get this working. And I do this. There it is. Okay, so you saw that while I had that connected, this resistor will light up and it will not burn out because the resistor is reducing the current. So, to review, current is charged particles flowing in a wire. We think of the current as flowing from the positive side to the negative side. By the way, what are those charged particles? They're actually electrons. Voltage is the push that actually makes the current flow. A battery has voltage, but there's no current flowing until we actually hook it up to a circuit, which is the complete pathway all the way from the positive through as many components as we desire, back to the negative. And finally, resistance is a push back on the current to limit it so that not as much power comes out of the battery. And that's important so that our components will behave as intended and are not overpowered and burn out. Now, one more thing is that these values all have units associated with them. So the value for current is known as amps, and you will see that abbreviated as A. The value for volts is the voltage is volts. You will see that abbreviated as V. There is no particular unit for pathway because it's either complete or it is not. And then resistance, the units is ohms, and you will see that abbreviated as this is a capital omega from the Greek alphabet. Another thing that you need to be aware of is in electricity, we use the metric system. So, for example, if we wanted a very small number of amps, you might see someone write it like this: MA, a small m, and then a capital A. This stands for, the M here stands for milli, which means 1/1000th. So a milliamp is 1/1000th of an amp. We would use something like this if we were doing a much smaller current. Similarly, another very, very commonly seen symbol that modifies these values is K. So for example, if we had a K and an omega, K here is equal to kilo. Okay, and that is equal to 1,000 times. So a kilo ohm would be 1,000 ohms. Finally, another very common one is a capital M, and should be distinguished from the lowercase m because m, let's say that this was megavolt, well, that would be a huge amount of voltage, and that is mega, and that is equal to 1 million. So this would be 1,000,000 volts. Okay, I just realized that I added in an extra L here, so this should actually be kilo just with the one L. All right, one final thing that I wanted to mention. It is actually very important that you kind of get a physical intuition for these quantities. It'll make your life a lot easier as you're building electronic circuits in the future. Sometimes people use analogies to describe how voltage and current and resistance behave, and actually circuits as well. So the analogy is like water. So electricity is kind of like water. Now, this analogy should not be pushed too far, but for example, voltage is like water pressure. You think of a tap, you put your thumb over you turn it on full and you put your thumb over it, it's going to be exerting a force. So water pressure exerts a current, and electric current is analogous, I'll say, is like water current. The flow of charged particles in the case of electricity, and the flow of water in the case of our water analogy. Okay, and then finally, resistance. It's kind of like you're pinching a hose. So imagine that you had a hose, of water's coming out of it, and you just gave it a little bit of a pinch, and it makes it more difficult for the current to flow out. It pushes back against the current, and it reduces the water. And so it's similar to resistance in the electric circuit.